Shall we take a gander at inverse tangent functions? We've looked at inverse sine functions and inverse cosine functions, and now we're going to take a gander at inverse tangent functions. So over here on the left, we've got our tangent function graphed, and we can see that we have a period between negative pi over 2 and pi over 2. So that's the period of our function. And if I look at my range of my function, I'm going from negative infinity out to positive infinity. So if we swap the x's and y's in this inverse function that we see here in the middle, what's happening here? Well, my domain actually goes from negative infinity to positive infinity, and my range is going to fall within that period. I should have just put R, but my range is going to go from negative pi over 2 to pi over 2. And similarly to the sine function, I see that my inverse tangent function values are going to correspond to the right half of that unit circle. So if we restrict the domain, let's say we got a restricted domain of the tangent function going from negative pi over 2, I probably should have done this first, to pi over 2. So that within that interval, our inverse is in fact a function, which it would not be if we did not restrict the domain. And our range here then is negative infinity to infinity. And we swap the values of the domain and the range to the inverse function. And so here we are, and this corresponds then to the right half of the unit circle based upon that restricting the domain of the tangent function. Let's evaluate a couple. So I left this right half of or I actually did the unit circle, but the right half of it for reference. And first we're asked to find the arctangent of negative square root of 3 over 3. All right, when I see that, first let's say I got a negative here. Remember that all students take calculus, which means if I'm only dealing with this right half, and I've got a negative value of the tangent, I know I'm down here in the fourth quarter. I'm going to be in that fourth quarter, that bottom right half. And then I'm thinking, okay, well, the tangent we know is the sine over the cosine. And that square root of 3 right there tells me this is either going to be something, or in this case, either negative pi over 6 or negative pi over 3 by virtue of that square root of 3 sitting there. That's kind of my clue. And I'm sitting here thinking, okay, what's at pi over 6? What is the cosine? Let's see, at pi over 6, the cosine is the square root of 3 over 2, 1/2. Well, let's plug that in as a tangent and see what that settles out to. So let's see, if I've got the sine, and this would be at negative pi over 6, I would have 1/2 over square root of 3 over 2, which then is going to equal 1/2 times 2 over the square root of 3, and those cancel, leaving me with 1 over the square root of 3. Then we want to rationalize that denominator by multiplying by the square root of 3 over 3. And shazam, what do we get? Square root of 3. Square root of 3 times square root of 3 is just 3. Boom. And of course this is all negative because we're in the fourth quadrant. And so we're going to be, let's say something right about there, at negative pi over 6. And that's going to be our arctangent, negative pi over 6. All right, what is the inverse tangent of negative 1? Well, negative 1. Well, the negative tells me I'm going to be in that fourth quarter. And if I'm thinking about my trig function values, my sine and cosine, well, at negative pi over 4, I should be at where the sine is negative square root of 2 over 2. And my cosine is going to be positive square root of 2 over 2. Well, put 3 instead of 2. 2. And that should simplify to negative 1. So the inverse tangent of negative 1 is negative pi over 4. Have to do a little bit of reverse thinking there, you know what I mean? Memorize those trig, the sine and cosine values of those general angles.